I'm going to show you some examples of extreme programming. Change. Anybody knows what that is? Sorry? It looks like a burn down chart, but it looks like really great, right? And we really hoped that the sprint was finishing here and not here. But there's also another line that just like trickles here and goes all the way down. No, so it's not a burn down chart. Anyone else? Dependency. So it's a dependency matrix, right? Of what? Of a constructor that has 90 dependencies. And the call graph goes 8 levels deep. So can you imagine a constructor that has to construct 90 different objects? This is real code in production. It really does work. It's crazy to maintain, but it does work. Okay? So that's a call graph. So now you know now you know that's not a burn down. It's also a dependency graph. Same class, different method. So this class has two methods. One is the constructor. And there's this other method. Not working. I'm going to put this down. That's the main method. It's 4,500 lines. It's a little bit better than the constructor. It's achieved more. It goes 13 level deep before it starts hitting the JDK, like the core libraries. And right at the top of the method, there's a begin transaction. Right at the end, there's a commit. And I was called in to help them because they had a performance problem. Right? So they solved the performance problem without me, and told the customers that this thing was calculating some really large insurance fund or like pension fund calculations for like, in South Africa we're a mining country, so few 100,000 people work at a mine, and so it's calculating really large things. So what they told the customers were, well, you can queue up. Take a number, queue up, we'll run this thing one at a time, serially. And they solved the performance problem in that way. So take a slot, and if you happen to get it at 9 p.m. that night, and you were actually doing pension fund calculations by 9 o'clock in the morning, you might have to want to phone them and get it done a little bit sooner. Right, so that's crazy thing. I didn't realize it was 4,500 lines because I was in an IDE, and I was like, click, you can like control click on a thing and you jump around, and I didn't realize I was in the same method. like where's this instantiated? Oh, over there. Oh, okay. So here's another one, different company. I've just put a fake UML diagram up, and these are counts of dependencies at namespace level, package level. That one's okay. How's that one? 95,000 dependencies between this and that. 43,000 dependencies between that and that. 10,000 is looking pretty good by this stage, right? Okay. 50. But that's not, even if we took the numbers and we divided it by 1,000, the problem is also the cyclic dependencies, right? So you've just got this thing completely intertwined, and it's hard to tease it apart. I got a class here, it depends on something here. The chances of that class having a dependency back here is pretty high. Which one should I change? If I tell you there's no CI, you'll be appreciative, right? Because if you try to write a test and run a test against that, chances it's going to fail every time on every commit is pretty high. Fortunately, when we looked into this, a lot of this was just by accident. People just didn't know where to put the classes. So by taking a few classes from here and moving them here, you actually like halved the dependencies. Right? It was just, people just put things in the wrong place. right? Now, it sounds so trivial in retrospect, but when you're given a class, which namespace should you put it in actually becomes a big deal. But it's easier when we do it wrong, and we know it isn't wrong. Okay, so what do we deal with this? So, being geeks, there's a bunch of us, and I'm not going to call names out or ask people to show hands. There's a bunch of you sitting here thinking, well, those developers know nothing. Right? They absolutely know nothing. There's a bunch of you considering it's a software craftsmanship thing, it's that you get excited. Because today you're going to refactor. Right? It's like, this is like the ultimate refactoring challenge you could have. You know, it reminds me of that guy from the movie 300. You know, that tonight we dine in hell. It's like, tonight we refactor, you know, and you're prepared. You're really ready for this. And the next guy, some of you might recognize the next guy, he scares the hell out of me. I like his books. I mean, his books create conversation. Thomas was saying you watch some of his videos and stuff, but he scares me if I see him in person. You know, he was at Uradev and I was at Uradev one year, and I stayed far away from him. I literally stayed far away from him. But essentially, we want to cleanse the code of all its evil, right? And a nice, gentle way of saying that is, let's go from smelly to clean. This code has a bit of a stench. And let's make it smell nice. Give it really rosy fragrance. Okay. So that's essentially what we end up doing a lot of the time, is that whether it's legacy code, our own code, we know the TDD cycle, your red, green, refactor. When you get to refactor, you're pairing, you're looking, someone's telling you over your shoulder, you're doing a pull request, someone looks at the code and says, well, there's a bit of a smell here, not really great. Let's clean it up, you know, spray some, blah, 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 and we ending up with code that smells nicer. Okay, so that's what we end up doing. And that's actually a good thing, because we know that code that doesn't smell gives us a better chance of doing things the second time to that code. We can touch that code a second or third time without the entire thing falling apart like what we saw with, 90 dependencies, right? So, anybody does closure in the room? Even for fun? Okay. So you can ignore all the parentheses, right? This is a little bit of closure. I'll explain it to you. So it says there's a function called pg10. It takes a list of kids, right? People, children. And it says filter the list of children. There's another function called over10, which will inspect everything, iterate through the list, and identify which kids are over 10, and return it. Okay? Return those kids that are over 10. So that's what that function does. And now imagine we've written this function. And we're really proud of this one-line function. Maybe as closure people are a little bit disappointed because it only has 2 closing parentheses, but that's okay. It's okay. And we carry on writing, and we do some more and more and more and more, and then we write another one, and we carry on. And then, like good software developers, we stand back, and we look at this, and we say, hey, look at those 2 functions, right? So even if you're not a closure person, you should be able to start doing some pattern matching just on a text level. And then we realize, hey, that says over 10. This one here says over 18. That says kids, that says teens. But more or less, the structure is the same. And so you have this duplication. And as good software craftsmen, or forget even if you're not software craftsmen, one of the things is don't repeat yourself. So we get rid of duplication. And so we create this new function called find that takes a predicate and an array, and it filters using the predicate over that array. The predicate is just a fancy name for give me a function to do, pass me a function. And so we can write those same 2 functions as find over 13, this changes applied to that array, or find over 18 applied to another array. So we get rid of duplication, okay? And we're really thrilled about that because now we've cleaned up the code. We've got rid of one stench. chances are that we could reuse this is pretty good. And so we carry on writing code, or perhaps it's someone else that's writing code now on the same system. Okay, they get stuck, they're not sure what they really have to do, and suddenly they remember that, hey, the other day someone had a commit, and they said, hey, there's this really great find function that we wrote, and they said, wow, let's put that in. Find a free seat for seats. Imagine this is for movies, right? PG-10, PG-18, trying to find seats for a movie booking. And, oh, great, now we can use that function. And it feels right, because we get some reusability. We're remaining pretty dry. So is this a problem? Anyone thinks it's a problem? Yes?
Well, conceptually, the two things don't really have anything to do with each other apart from the predicate
Yeah.
over a list.
Yeah. Okay.
They're two very different domains.
Right. So essentially what we're saying, don't repeat yourself. I could use, we got rid of duplication here, created this really abstract function, and we can use it in 3 different ways. It also means that I could use it like this. Find evens across that. Exactly what you were saying. The domain of numbers got nothing to do with the domain of movies, right? So is this a problem? Potentially yes. Potentially yes. Because that find function is now at a significantly different level of abstraction. It's no longer bound to that domain in which it was conceived. Okay? And what I found in the way that I work is that I call it a pathological approach to refactoring. So pathology is a study of disease, right? Right? Of diseased cells, basically. And so when I first started doing software development, and I read Martin Fowler's book on refactoring, and then Clean Code by Robert Martin, and a whole bunch of other books, and you feel really empowered, and then your IDEs come along, and it's like extract method, and it's Control-Alt-F something, and suddenly you can extract variables, extract methods, and pull up and push down, and all sorts of stuff, and you just have these recipes of cleaning up your code, right? And it's fantastic because you're just getting like a super whiz kid with your IDE, and your code starts shrinking in size, and we have all of these great things. So the approach there is to basically kill the disease, clean the stench. Okay, but the thing is that when we come here, right, and this is where it started changing for me a few years back, is that when we take those 2 functions that we want to get rid of them, right, we're actually conceiving a new abstraction. It's a change of knowledge that's happening here. Okay, exactly as you were saying, it's a change of knowledge. The fact that it's now unbound to that particular domain, it means that it is a different thing altogether. It's expecting us as software developers to think at a different level of abstraction. And so this is not motivated anymore by just a few refactoring steps to clean up the code. It's a change of knowledge, and it's relevant within the context or relevant across many contexts. The result of something like this in particular is that it's at a level of abstraction that is not bound to a domain, which means that you can end up with several dependencies upon it that we never anticipated. And dare we go start making changes, and it's a trivial example, but dare we start making changes. For example, let's just say we started memoizing this for performance over really large collections, right? And suddenly a whole bunch of things in other parts that were dependent upon this thing that's at a different level of abstraction starts failing or behaving in an inappropriate way, in an unexpected way. So perhaps it's just about scope. Where should we place this thing, or how did we get access to it? Maybe it's a name issue. Maybe we could come up with better naming. It'll be a hint to someone, oh, please be aware, this is really generalized, blah, blah, blah. Most of the time what I've found is that if you can resolve those 2 issues, most of the time, every single time I've attempted to go dry, I've invented a new abstraction. Every single time. When I do extract method, extract variable for an expression, the first and most difficult thing is not the keystrokes, but what am I going to call that thing? What is the name that I'm going to apply to the thing that I'm extracting? And that's the first sign that we're actually creating a new abstraction. We're inventing knowledge. Okay. So my approach to refactoring is that refactoring shapes and packages the way we express our knowledge. It's not just about cleanliness. It expresses our knowledge in a different way. And then some things change when you take that attitude towards refactoring. So I'm not saying it's different refactoring techniques. I'm saying is that our attitude towards refactoring is changing. Well, for me it did. So if I take this Python code, define top customers, the first line is basically sort the customers by total sales, slice the list by taking the first 5, which are the top 5, get the bottom, everything from 6 onwards, total up the bottom, and return the top 5 and the total. Not horrible. Extremely easy to read, really nice and simple. Now, what if I wrote it like this? Exactly the same thing. Take top of customers by slicing the first 5, and another function called rest of the customers from 6 onwards. And what if so now here we're emphasizing top and rest. And if we go further, here's the same function written in a different way. Here we sort it, then we're using the take function to get the first 5 and the drop function to get the rest of it, and then we construct it in that way. So if I put all of them together, there's the first version, the second version, third version. Which one is the nicest one? Which one is the cleanest?
I would say the top one, because you don't have to be a Python developer to understand it.
Okay. Right. But assuming we're all Python developers, which one is the cleanest? It's hard to say, right? They're all pretty reasonable. But the thing is that each one emphasizes a different aspect of the knowledge embodied in here, right? So this one here talks about top 5 and bottom. This one talks about top and rest. This one talks about take and drop. So as a reader of the code, I'm leading the person who's reading this code into a particular knowledge space that actually emphasizes certain things. Each one has at the face level equal clarity, but it's different concepts that are being presented. Yes?
The second method there, you don't see it sorts the customers, all the sales. I would assume it would take the first 5 of that list.
Maybe top actually does it. It's a good spot,
Yeah.
but maybe top actually sorts it and takes 5.
But I don't see it that. So
Yeah.
it's all.
Okay. Right. But again, it's what do we want to emphasize?
Yeah.
Where this one here emphasizes sorted. This one here says, well, you really don't care, I'll deal with it.
Yeah.
Okay. So here we're talking about refactoring motivated by expression of knowledge. What do I want to emphasize? What do I want the next person who's using this code to read and absorb first? That's a big difference for me. So this is what I always ask. Will these refactoring steps destroy, enhance, or retain the conceptual integrity of my design? And conceptual integrity comes from 1975, a lesser-known paper by Fred Brooks from the Mythical Man-Month stack of papers, where he says he contends that conceptual integrity is the most important consideration in design. It is better to omit than to have a system that contains independent and uncoordinated ideas. And what it basically boils down to is this. It is a model that you install in the mind of the user. It is this concept that you put into the mind of the user. Whether it's an end user working on your system, or whether it's another developer working with an API, or another developer maintaining this piece of code, it is the model that you install in the head of a user. That's conceptual integrity, right? Give you an example, JUnit. Class, setup, test, they'll get tear down. RSpec, Ruby, class, well, the test class essentially, setup, test method, assert, tear down, if there is one, right? Both RSpec and JUnit have the same conceptual model. Then RSpec 2 point something comes up with this method called let. And many people started replacing the before block with let. And if you go to Stack Overflow, you'll see endless discussions about let versus before. Right? And it's just a version change, and a new keyword was introduced. And the thing is that almost every single time, let will act like before. But let is evaluated lazily, it's not cached across examples, so it can behave like that. But it is not before. So this is where we destroy conceptual integrity in the mind of the user. We're now given two things that looks like can behave like that, and so we actually can use it like that, but it wasn't really intended for that. You know, it's like kind of using a wheel spanner to open your beer bottle. You can do it, but not intended for that. So that's the kind of thing that happens. How you fix this, I don't know. I haven't even thought about it. So here's my approach. When you refactor, never mess up the mind of your user, which is another developer as well, right? Otherwise, you end up with extreme programming, like what we spoke about. Okay. So this is what I believe, right? And it's only been in recent years, like under 5 years, maybe under 3 years. I write software so that I can give clarity of thought to others. That's my intention. If I write code, whatever I ship out must result in clarity of thought to the person who's using that software. I cannot write code. I cannot fulfill that. I cannot write code if I cannot express the knowledge that I want them to absorb. So this is not a reactionary muscle memory type of refactoring. It is genuinely thinking about the knowledge that I want to express. So I found that when I write code like this, I focus outwardly. I don't focus inwardly. With the muscle memory style of refactoring, I think about my goals for clean code, whereas this here makes me focus on the person next to me. So this is what I call Ubuntu coding. So 97 things that software programmers should know. Anyone seen that book? I wrote an entry that was accepted by Kevin Henney, and it is what I call Ubuntu coding. So Ubuntu, you know the OS, right? The distro. Ubuntu is a South African philosophical concept where I come from. It's a Zulu concept, which basically says that people are people through people. People are people through people. So I exist because you allow me to exist because you do certain things that help me to exist, and it's reciprocated. Okay. And I reduce it down to code, that code is code because of code. So if I write code that is conceptually broken, the chances of you using that API that's conceptually broken means that this is definitely going to be a part of your code that is going to degrade to the level of my code. That's going to happen, without a doubt. I mean, you can imagine the constructor that I showed you, right? Imagine the poor guy has to call that constructor. Right? I can tell you it took one argument. You know what that argument was, right? The constructor took one argument.
String.
Hash map. With 90 things in it, right? So this is what I found, is that it helps me focus on the people that I work with. It gives me an appreciation of things that I want them to succeed. That's what it does for me. Wrapping it up, so I like to refactor continually over days, weeks, and months. It's not a single session. Clean code is the end game, and it's way over there. It might be years later. So I like cleaner code with every programming episode. I don't aim for clean code, and that's it. It's now clean. It's done. I refactor to emphasize knowledge, and I really want to think about what do I want the next person to understand. What do I want to bring to the surface? What do I want to push down? I try my best not to destroy conceptual integrity, and I'm aiming for that. Clarity of thought. I find that if I focus on clarity of thought, clean code comes quite naturally. That's what I focus on. And this is the way I live my life. I find it's much more balanced when I have clarity of thought. Otherwise, it's completely disastrous. So that's my little bit that I've thrown down about the way I approach refactoring.